So let's talk about rational functions. So a rational function, it is in the form of f of x is equal to a over bx plus c. As you can see here, on the denominator we have x. So this is a rational function. So the question is saying, sketch the graph of each of the following function, state their domain and range, and clearly identify or intercept and asymptotes. So let's start with part A. So part A is f of x, which is equal to 7 divided by 5x plus 10. How do we find the domain of the rational function? So to find the domain of the rational function, get the denominator, set it not equal to 0. So I'll say 5x plus 10 is not equal to 0. Why are we setting it not equal to 0? Because we can never have a function a over 0. This is going to be undefined. So the denominator should not be equal to 0. Then solve for x. Okay, so in this case I'm going to say 5x is not equal to, I'll shift 10 to the other side, is going to be negative 10. I'll divide both sides by 5. 5x should not be equal to negative 2. Meaning that my domain in that case is going to be all the values from negative infinity to negative 2, but this negative 2 is not included, union from negative 2 all the way to positive infinity, not included. Or I can put this in set builder notation. I can say the domain will be x is such that x is not equal to negative 2. At the same time, x is a member of all real numbers. Okay, now when you find the domain, in this case we have said x is not equal to negative 2. So the domain is the vertical asymptote. In that case, vertical asymptote is going to be negative 2. So if you find the domain, the same domain which you have here, that is your vertical asymptote. Meaning my vertical asymptote is going to be what? It's going to be negative 2. But for now, let's first talk about, let's first find the domain and the range. So we are saying that the domain for this function is from negative infinity to negative 2, but not included, union negative 2 to positive infinity. So then how do we find the range? If you want, you can find the inverse of this function, but here I'm going to use another principle. To find the range in this case, we're going to see if the function is bottom heavy, then the range y is not equal to what? Is not equal to 0. Okay, meaning that my range in that case is going to be from negative infinity to 0, union 0 to positive infinity. Or I can say y is such that y is not equal to 0. If the function is bottom heavy, if the degree of x on the denominator is higher than the degree of x on the numerator, then y is not equal to 0. At the same time, that 0 is going to be our horizontal asymptote. Okay, now that we have found this, let's now go ahead and, so now for part A, I want to start with domain, range, then also I have to identify the intercept and the asymptote. Now how do we find the asymptote? So to find the vertical asymptote, get the denominator, set it equal to 0, solve for x. So in that case, it's going to be 5x plus 10 is equal to 0. 5x will be equal to negative 10. I divide by 5, I divide by 5, x will be equal to negative 2. Like I said, x was not equal to negative 2. This was our domain. The domain is the same as the vertical asymptote. Okay, So now that is my vertical asymptote. To find the horizontal asymptote, if the function is bottom heavy, if the degree of x on the denominator is higher than the degree of x on the numerator, the horizontal asymptote is always 0. Okay, so in that case the horizontal asymptote is going to be 0. Now how do we find the intercept? To find the x-intercept, set y to be equal to 0. So I'm going to say 0 is going to be equal to 7. I have to find the value of x plus 10. If I cross multiply, I'm going to find that 0 times everything down here is going to give me 0. So it's going to be 7 is equal to 0. We can clearly see that there is no x here. So this equation, this rational function has got no x-intercept. So we don't have x-intercept. Let's see if we have y-intercept. To find the y-intercept, set x to be equal to 0. So it's going to be y is equal to 7. Where there's x, I'm going to put, I'm talking about here, where there's x, I'm going to put it's going to be like this, meaning my y will be equal to 7 over 10. So when x is 0, y will be 7 over 10. This is the one which is going to help us even to sketch. Now if this is my graph here, our vertical asymptote is at what? Is at -2. I'm going to put -2 here. So I have to put a dotted line. Then horizontal asymptote is at 0. Now we are going to say we have 0, 0,7 point or 0,7 over 7 over 10. So I'm going to put 7 over 10 here. So 0,7 over 10, it is at this point. Okay. Now what we're going to do there is that it's going to start from there. It has to touch this line, then going there, but not touching the asymptote, running away from the asymptote. Now the way we are doing it for rational function, you are going to reflect this to the other side. In this case, I'm going to reflect this graph here. Then that is going to be my graph. I have to indicate the intercept which I have. In this case, I've got 0,7 over 10. I've indicated here this point, and it has to touch that point. Okay, so for part A, this is the graph. So if you want, you can put the numbers here. You can say this is 1, -1, this is 1, this is 2, 1, 2. You even put some numbers there. That is just okay. So that is it for part A. Okay, let's go ahead and do part B. So part B, we have f of x to be equal to 6 minus x divided by x minus 3. Once again, to find the domain, we have to get x minus 3 not equal to 0, x not equal to 3, meaning that my domain will be from -infinity to 3 but not included, union from 3 to +infinity not included. I can say x is such that x is not equal to 3, x is a member of all real numbers. That is my domain. Now after finding the domain, we can also find the vertical asymptote. The same number here, x is not equal to 3. That is my vertical asymptote. I'm going to say my vertical asymptote is at 3. That's all. Now how do we find the range? We said if the function is bottom heavy, y should not be equal to 0. That is the range. If the degree of x is the same on the denominator and on the numerator, you divide the coefficient of the x. So in this case, we have got the coefficient here where this x is -1 divided by 1, meaning that it's going to be y should not be equal to -1. But again, if you want, you can make x as a subject of formula, then you are going to find. Now at the same time, meaning that my range is going to be from negative infinity to negative 1 union negative 1 to positive infinity. Now, what we have to remember here is that the same range we are saying that y should not be equal to negative 1. That is my vertical asymptote, my horizontal asymptote at negative 1. As simple as that. Now, I have to find the intercept for me to sketch this. So I'm going to say, to find the x-intercept, y has to be equal to 0. So it's going to be 0 is equal to 6 minus x, then I've got x minus 3. Here I divide by 1, so I cross multiply, see, it's going to be 6 minus x is going to be 6 minus x. I have 6 minus x is equal to 0, because if I do 0 times z, everything here is going to give me 0, and then I'm going to have negative x is equal to 6, negative 6, negative negative will go, x is equal to 6. So what does it mean? When x is 6, y is 0. That is my y-intercept, my x-intercept, sorry. Now to find the x-intercept, to find the y-intercept, x has to be 0. So it's going to be y is equal to, so I'll say y-intercept on top. So y has to be x has to be 0. I'll say x has to be 0. So I have y is equal to 6 minus 0 over x minus 0 minus 3. So I have my y-intercept to be negative 2. So it's going to be, when x is 0, y is going to be negative 2. Now I can have my graph. So here is going to be my graph. So remember, I have got the vertical asymptote at 3. I'll put here, so it's not supposed to touch this line. I have the horizontal asymptote at negative 1. I'll put it there. Next, 6, 0. Where can I find 6, 0? It's going to be somewhere here. Let's say this is 4, this is 1, this is 2, 3, 4, 5, 6. Let's put it at this point. Then negative 0, negative 2 is going to be somewhere here, because this is negative 1, so negative 2, 0 is going to be here. I'll put 2 here. So this is going to come like this. It has to touch that line, then going there. Again, here we have our point. It has to be reflected here, so it will start from here going there. So it has to go there. You put an arrow because we don't know where it is ending. Okay, so in that case it is like this. It's going like that. So that is our graph for part B. Now we go to part C. In case you are having some challenges on how to reflect it, if I have this, if the graph is here, then it has to be reflected this side. If the graph is here, it has to be reflected that side. That is the principle. So as you can see here, we had a graph here, so it has to be reflected this part. If we had this graph, this part here, it would have been reflected there. Yeah. So now let's go to part C. So part C is saying f of x to be equal to 8x plus 8 divided by 4 minus 2x. So to find the domain, like we said, 4 not equal to 0, we solve for x. 2x not equal to negative 4. Okay, I'll divide both sides by negative 2. X will be not equal to what? 2. That is my domain. So my domain is going to be from negative infinity to 2 not included, 2 not included to positive infinity. At the same time, this is my vertical asymptote. My vertical asymptote is going to be at 2 because I have to get this, set it equal to 0, so for x. That is my vertical asymptote. To find the range, we know that if the numerator and the denominator are having the same degree of power of x, then we divide the coefficient. In this case, I'm going to say y should not be equal to, I'll divide 8 divided by -2, which is going to give me -4. So my range is going to be from negative infinity to -4 not included, union from -4 to positive infinity. At the same time, my horizontal asymptote is at -4. So the range is the vertical asymptote, the domain is my the range is my horizontal asymptote, the domain is my vertical asymptote. That's the principle which is there. So now I'm going to get rid of this and say my vertical asymptote, my horizontal asymptote is at -4. So I have to find the intercept. So how do we find the intercept? To find the x-intercept, set y to be equal to 0. So it's going to be 0 is equal to 8x plus 6 divided by 4 minus 2x. I divide here by 1, then I cross multiply. Now from here, I can see that I'm going to have 8x plus 6 is equal to 0 times everything here is 0. So it's going to be 8x is equal to -6. Then I divide it by 8, I divide it by 8, x will be equal to 2 into 6 is -3, 2 therefore. So when x is -3 over 4, y is 0. That is my x-intercept. I go to y-intercept. How do we find the y-intercept? To find the y-intercept, set x to be equal to 0. So I'm going to say y is equal to 8, where there's x I'll put 0, plus 6, I'll divide this by 4 minus 2, 0. So my y will be equal to 6 over 4, which is the same as 3 over 2. So when x is 0, y has to be 3 over 2. As simple as that. Now let's try to sketch this. So you use sketching, it's very easy. We have just to use the intercept which we have just found. Okay, so if our intercept is not going to be correct, then it's going to be hard for us to find the correct answer. So in this case, we know that our vertical asymptote is at 2. Or let me just do this. Is at 2, so I'll have this. At 2, that's where I have my vertical asymptote, so it has to cut there. Okay, then the horizontal asymptote is at -4. At -4, so I'm going to put -4 here. That is my horizontal asymptote. Now we can see that where can we find -3 over 4, 0? That point is supposed to be here. X is negative, so it's going to be somewhere here. It's going to be, because -3 over 4 is approximately 0 point something, so I can say it is just near 0 here at this point. Another one, we have 0,3 over 2. Where can we find 3 over 2? 3 over 2, we can find it here. It's 1 point something, which is just here, meaning that it's supposed to touch this point here. Starting from here, touching these 2 points, then going there. but learning away from the asymptote. Now I have to reflect this down here, so this is going to be like this. So that is going to be my graph. Okay, that is going to be my graph, and this is not part of the graph. You can just get rid of this. Yes, so that is going to be our graph. So as long as you know how to find the intercept, then the graph is going to be easy for you. So that is it for C. Now let's go ahead and find and graph D. D is f of x is equal to negative 2 divided by x squared minus 5x. So to find the domain, we get x squared minus 5x not equal to 0. We solve for x. I can factor out x here. So x will be x minus 5 not equal to 0. X not equal to 0 and x minus 5 not equal to 0. So x not equal to 0, x should be not equal to 5. So the domain is going to be from negative infinity to 0, not included, union from 0 to 5, not included, union from 5 to positive infinity. That is my domain. Okay. Then I also know that my domain, these values which I've just found here, this is my also vertical asymptote. So my finding vertical asymptote, we are just setting this equal to 0, solve for x. So it's the same as in I have 2 at 0 and at 5. What of the range? To find the range, you can first find the horizontal asymptote. So if the function is bottom heavy, the horizontal asymptote is 0, meaning the range is y should not be equal to 0. Okay, so y should not be equal to 0. We are going to have negative infinity to 0, union 0 to positive infinity. So that is my range. Then now I have my my horizontal asymptote and vertical asymptote. Now I'm remaining with the x and y intercept. To find the x intercept, y has to be 0. So it's going to be 0 is equal to negative 2x squared minus 5x. If I cross multiply here, I'm going to have negative 2 is equal to 2. X is not existing here, so we don't have x intercept. You say no x intercept. Then you go to y. So I'll say y, to find the y intercept, x has to be 0. So y will be equal to negative 2 x, this is going to be 0 minus what? 0 minus 0, which is going to be undefined. We also don't have what? The y-intercept. So how are we going to sketch our graph? Okay, if we don't have the y-intercept, this is what we are going to do. We're going to have our graph, which is going to be like this. I'm going to use the coordinate. Okay, I'm going to use the coordinate. So if I want again here, okay, I'm going to use the coordinate, and the coordinate which I'm going to use in this case, I'm going to do this. I'll say x, y. Then we are saying that x should not be equal to 0, at the same time x should not be equal to 5. I'm going to plug in the values. In this case, I'm going to put, I have got 0 and 5. I'm going to put 2 numbers up, 2 numbers down. Again here, 2 numbers up, 2 numbers down. So I'm going to start with negative 2. Or if I want, I can just put one number. I'm going to put negative 1. I have to jump 0, then I'm going to put 1. Okay, then again 5, a number on top of 5 is going to give me what? is going to give me a 4, and then let me put also 6. So in this function, if I put -1, what do we expect to have? It's going to be -2. We have -1 squared, that is going to be -1 squared is 1. It's going to be 1 minus 5, or 1 plus 5, which is going to be -2 over 6, which is -1 over 3. So I have -1 over 3. Now if I put 1, let's see, if I put 1, it's going to be -1, then I'm going to have 1 minus 5, which is going to be -2 over -4. This is going to give me what? This is going to give me 1 over 2, which is half. What if I put 4? But before I go anywhere, even here I can see something which is going to be like this. Before I even finish, I can graph using this. Just those two to coordinate, because the main important coordinate which I have, the one for positive, this is the only one I'm going to have for positive. So I have this. I'm going to have, I have at 0, I have my vertical asymptote. Also at 5, okay, at 5. So I'm going to say this. Now if I go there and say where, or if I want, I can even plug in 4. Let's see, if I put 4 where there is x here, is going to be 4 squared is going to be 16. So I'm going to have -2 over 16 minus, what is 4 times 4 times 5 is 20. I'm going to have -2 over 16 minus this one, 16 minus 20 is going to give me -4. Again, I'm going to have half. Okay, I'm going to have a positive. So what next? I'm going also to have 6. If I put 6 there, it's going to be 6 squared is 36 minus 6 times that one is 30. I'm going to have -2 over 3. Then it's going to go back to -1. It's going to be 1 over 3. So now from here I can see that I have -1, -1 comma 1 over, let me put 1 here, -1 to be here, then that -1 over 3, let's put it here. So horizontal asymptote is 0. Let's not, we have to put 0 here. So I'm going to put this point to be -1 over 3, meaning at this point, that is where I'm going to have that one. So I have 1 comma 1 over 2. In x I have 1. Let's say our 1 is here. Okay, so we have our 1 in x is here, and our y, half in y, let's say it is somewhere here. So I'm going to have this point. Another one, I have got 4 comma in x 4, which is here. Okay, 4 here. Then again I have got that point. Okay, so if you have got 2 points here, another point which we are going to have is 6. That 6 is somewhere here, and that is going to give us negative. We said -1 over 3 is going to be somewhere here. It's going to be here. I can see from here that my graph is going to be like this. I have these 2 points. If I've got these 2 points, this graph is going to come like this. It has to come there, then it goes there. Then I have got also these points. It has to touch that point. This point going there, not touching the asymptote. Again, this point going here. As simple as that. Now I've used this method because I don't have the x-intercept, I also don't have the y-intercept. That's the reason why I've just gotten, if you discover that you don't have x-intercept and y-intercept, what you're going to do is you have to get the vertical asymptote. In this case we've got 0, so you have to get two numbers from the right, two numbers from the left, or you can just get one number, it's okay. One number from the left, one number from the right. At the same time, you have got 5. You have to get it one number from the right, which is going to be 6, and one number from the left, which is going to be 4. Now plug in here and then sketch it. It's going to come out perfect. So that is D. Now let's see how we can sketch E. So E, I have f of x to be equal to x plus 3, then x squared plus 4x minus 5. But before we solve E, in a case where we have f of x is equal to x squared minus x plus 1, how do we tend to find the vertical asymptote? So if the numerator is has got the highest degree of power, we don't have the horizontal asymptote. We said that if the denominator is having the highest degree of power, we say the horizontal asymptote is 0. If the numerator and the denominator, they are having the same degree of power of x, you get the coefficient, you divide them. So in a case where the numerator has got the highest power of x, you don't expect to have what? Horizontal asymptote, meaning we don't have horizontal asymptote. Okay, so now let's go to E. E is saying, we know that to find the domain, we have to get this, set it not equal to 0. We know that the product in this case is -5, the sum is 4, the factors, what will be our factors? In this case my factors will be +5 and -1, because +5 times -1 is going to give me -5. +5 minus 1 is going to give me 4, which is true. So I'll have x plus 5, x minus 1 not equal to 0. So x should not be equal to -5 and x should not be equal to 1. If the coefficient is 1 here, I just get the factors which I have to be my answers. So my domain will be from -infinity all the way to -5, union from -5 all the way to 1, union from 1 to +infinity. At the same time, my vertical asymptote is at -5 and 1. Now let's find the range. To find the range, in this case, this function is bottom heavy. The degree of power of x on the denominator is greater than the degree of power of x on the numerator. So y is not equal to 0. So the range will be from -infinity to 0, union 0 to +infinity. Now this is also our horizontal asymptote at 0. Now I can have my x-intercept. To find the x-intercept, y has to be 0. So 0 is going to be x plus 3 divided by x squared plus 4x minus 5. Next, I'm going to cross multiply. I'm going to have x plus 3 is equal to 0 times everything here is 0. X is equal to -3. So when x is equal to -3, y is 0. That is my first intercept. So that is my x-intercept. Let's find the y-intercept. So when y is equal to 0, when x is equal to 0, so to find the x has to be 0. So it's going to be y is equal to 0 plus 3, where there's x I am putting 0, 0 plus 0, 0 plus 4 times 0 minus 5, I'm going to have 3 over negative 5. So when x is negative 3 over 5, my y is 0. That is in my x-intercept. Now I'm going to have my graph. I have everything. So I'm going to have, here is my graph. So at negative 5, I have my asymptote, and at 1, I also have my asymptote. So I have 2 points. Negative 3, comma 0, I can find this point here. This point here. Because I can say this is, or let me just do this. This is negative, this is negative 1, this is negative 2, negative 3, negative 4. Meaning this point is here. Negative 3, comma 0. Negative 3, comma, negative 3 over 5, comma 0, I can find this point somewhere here. Yes. This means that if I've got 2 points which are just opposite to each other, this means that this graph is going like this. It has to touch this point, it comes here, it comes like this. Now what you have to do is, this part here, this part, you can see that at this point this has to be reflected. We have forgotten to put the horizontal asymptote. This part here, we know that this is our point and this is our point, and this is where this is turning. This has to be reflected that side. So this side I'll also have this. Again, this side is turning at this point, so it has to be reflected this side. So I also have another, I'll reflect it this side. So that is my graph for E.